Greetings everyone, we will continue our discussion on programming for problem solving using C. In the previous session we have started about structures and we have known how to declare structures and how to use structures in our program. In this session we will be going for some more related topics regarding structures and we will be learning about unions and typedef. So first, in the previous session we have started about what is a structure. So usually you will be able to store a single information in your ordinary variables, and you can be able to store large number of large number of information values but of the same data type in arrays. If I want to store large number of values of different data types, then I have to go for your structures. So structures will provide this where the structures will provide you this opportunity where you can store dissimilar data types under a single name. So if I want to store, as I told you, if I want to store 3 books information which are having the various string, okay, so if you want to store 3 books information and if the particular book name has name, price and pages which are of different data types, that is string, float and int, at that time you can implement it by either using individual arrays to store the individual elements, that is name, price and pages, or you can use the structure variable. So this is an example where you can use the individual arrays, okay, where your name is one array, price is another array, pages is one array. So you can implement that by using simple arrays, but you can see that as the number of books increase, you will be having too much of a problem of creating large number of arrays. As the number of elements increase, you have to create new array. So managing too many arrays in my program will make it slower and it will not be effective and it looks clumsy. So to better efficiently use, you have to go for your structures, where you can create your structures in one form and you can use that particular structure to create large number of variables which represents individual elements. That is, here you have created one book structure. Using that book structure, you have created 3 elements, B1, B2, B3. It will represent book 1, book 2, book 3. So book 1 will be having its own set of parameters, that is name, price, pages. Book 2 also will be having its own set of parameters, name, price and pages. So we can implement that by using the structure as well. So the structure implementation will be much easier compared to your arrays implementation. So in order to do that, first you have to be able to declare your structure. The structure declaration will be done by using your struct keyword, and then you have to specify the name of the structure, and inside the book structure you will be having the structure names, structure members, which will represent the properties of that particular book. Okay. So to declare the structure, you have to use the struct keyword, then the name of the structure, and inside the flower braces you have to specify the properties which can be different data types, and at last you have to place the semicolon. And to create the structure variables, first you have to declare your structure name, structure. So when you create the structure, you are not providing any memory to that one. The memory will be assigned only when you create the structure variables. So to create the structure variables, you have to specify the struct keyword, then the name of your structure. After that, the commas, with the commas you can specify the number of structure variables you want, that is B1, B2, B3. So B1 is one book which will be having its own name, price and pages. B2 also will be having its own name, price and pages. So this is one way to create your structure variables. The another way is while declaration itself, that is while declaring you will write the structure. Before placing the semicolon, I will be giving all the structure variables which I want in my program. Both are valid declarations, and you can create the structure variables in this manner or you can create the structure variables in this manner. Once after creating the structure variables, you can initialize them. Okay, while the creation of structure variables itself, you can initialize the values like this. That is struct book B1, I will be giving the values for the specific properties, that is name, price and pages. Basic will be the B1's name, price will be the B1's price, and 550 will be the B1's pages. So by this you can create the structure variables and initialize them while declaring itself. Okay, this is one way to give values into your structure variables. The other way is by accessing the individual structure variables. In order to access the individual structure variables, we can use the dot operator. So we can use b1 dot pages, b1 dot price, like that. So we can use the dot operator to access the individual elements of a structure variable. Okay, so this is the complete program of your structure, where you have created one structure book and then you have created the structure variables. So this will be the input part, where you are giving input into the structure members, and this is the output part where you are printing the structure members. So while inputting, I am accessing the b1's name by using b1.name, b1.price, b1.pages, like that. So we have to use the dot operator to access the individual elements of a particular structure variable. So this is the introduction regarding your structures. Now we will be looking about the related concepts about structures. Next is how the structure elements are stored. Okay, whatever may be the elements of your structure, they are always stored in continuous memory locations. So when you are having your structure, struct book, okay, so we will be having name, char name, then I am having float price, int pages. This is the structure declaration you are having, and I am creating one variable b1. Okay, so now after creating variables, you can assign the values b1.name is equal to b, b1.price is equal to 130, p1.pages is equal to 550. So when you see the character name means it will occupy 1 byte, float price means it will occupy 4 bytes, and int pages means it will occupy 4 bytes. Okay, completely we will be needing 9 bytes to store one book. If I have another b2, I can need another 9 bytes. I will be needing another 9 bytes. Whatever may be the elements of your, whatever may be the elements that are present in your structure, okay, all the structure elements related to one element will be stored in continuous memory locations. If you see here, so b1.name, which will be present in 65518 memory location. So since it needs only 1 byte, it will be present in this particular location. Next, b1.price, that is the price requires 4 bytes, so it will be present between 45519 to 45522. Okay, so 23. So those 4 bytes will be used by price. After that, b1.pages also will be using another 4 bytes. So 1 byte, 4 bytes, 4 bytes, complete 9 bytes of memory will be assigned for one structure variable. In the similar case, if I have b2, so b2 also will be having the next 9 bytes. Okay, in this manner your complete structure members will be stored in your memory. So whatever may be the size, whatever may be the type of your members, all will be stored in continuous memory locations. Next topic is regarding array of structures. We can also declare an array of structures. You are having a single structure variables now. Each element of the array represents one structure variable. For example, struct employee emp of 5. So if you see, you have created book, struct book b1, b2, b3. You have created 3 variables b1, b2, b3. If I want to create 100 variables, I cannot write b1 to b100. So to avoid that, we are creating or using your array of structures, where you can specify book b of 100. Okay, where I am creating 100 structure variables. The 100 structures variables will be from b0 to b99. Okay, if I want to access thirds, b1 third, that will be b1. Okay, if I want to access the third element, that is third book, that will be b2 book, and if I want to access its pages, b2 dot pages. That is how you can access the elements by using your array of structures. So instead of having one declaration like this, you can declare any number of variables by using arrays. So that will be calling it as array of structures. In this example, struct employee is the structure here, emp is the name, just like your b here, and I am creating 5 employees here. Okay, I am creating 5 employees. Each employee will be E0 to E4. That is, the employees which will be created are EMP0 to EMP4. So those number of employees will be created by using that statement. So this is an example regarding your array of structures. Initially we have declared stdio.h. After that I have created my employee structure. Inside the employee structure I am having only 2 things. One is the employee name, which is represented by string. The another is salary, that which will be represented by your integer. After that I have created 5 employees. That is, I have used the array of structures and created 5 employees. Struct employee emp of 5. So you specify your array of structures here. So now, as I told you, emp of 0 to emp of 4 will be created. Then I have declared 2 variables I and j. Okay, so as you have seen, you have created your basic array of structures. Then I have created I, j. Okay, so all the operations I am writing in one function, that is ask function. I am writing all the operations in one function. So if you see, for I is equal to 0, I less than 3, I plus plus. So you are having employee of 0 to emp of 4. Even though I have created 5 employees, in this example I am using only 3 employees only, that is 0, 1, 2. Okay, you need not use all the 5 employees by the declaration. You can use only whatever the number you need. That is, you have declared 5 employees and you can use 3 here. That is 0, 1, 2. Your for loop is working from 0, 1, 2. So for each and every employee, that is for 0 employee of 0, I am taking the name and salary input. This is the input part. Okay, employee 0 dot ename, employee 0 dot salary. Next 1, I value will become 1. Employee 1 dot ename, employee 1 dot salary. Next I value will become 2. Employee 2 dot salary, employee 2 dot ename, like that. So we are taking input here, then the same process we are going to use to display the output. Okay, displaying employee record. For I is equal to 0, I less than 3, I plus plus. The same thing. Employee I, that is employee 0 dot ename, employee 0 dot salary. Like that you can use the same thing. So if I want all the 5 employees, I can be using something like this. For I is equal to 0, I less than 5. For I is equal to 0, I less than 5. So that I will be using all the 5 employees that are declared here. Okay, so this is how you can create an array of structures and you can access them by using this particular dot operator by the name of the particular element. Okay, so this is about array of structures. The next topic regarding your structures is nested structures. Nested structures means that one structure has another structure as member variable. Okay, you can be having one structure inside another structure. So that we'll be calling it as nested structures. So if you see an example, this is the outer structure, that is student. Inside the outer structure you are having one variable, that is name, another variable, that is age, and the third variable is address, which is another structure. So having a structure inside another structure, we will be calling it as nested structures. This is the inner structure what you are writing here. The inner structure is your address, where you are having locality, city and pin code, and I am creating one variable addr. Okay, now if I want to create variables, how I have to create? I have to create struct student S1. If I want to access name, directly I can access S1.name is equal to A. If I want to access age, I can directly access age. Age is equals to 100, 40. Or you can access address. Since the address is a inner structure and there is a variable for that particular inner structure, I have to use that variable as well. Okay, ADDR. After that I have to specify the locality. Okay, so I have to access the inner structure variables in this manner. I have to use the variable of your original outer structure and then the variable of the inner structure, then I can access the locality. So locality is equal to some B and s1.addr.city is equal to some H, s1.addr.pincode is equal to 515 something. So that is how you can access your nested structures. So having one structure inside another structure, we will be calling it as nested structures. You can perform your nested structures and access those nested structures in this manner. So first you have to create the structure variable for your outer structure and then can access them one by one in this manner. Okay, so this is regarding your nested structures. So the next topic is regarding unions. So unions are conceptually and structurally similar to your structures. Okay, so unions and structures are almost similar. The syntax to declare, define a union, and also the accessing part, most of the parts, the outer explanation that is regarding the structures, it will be same for unions. That is how to declare your structures, how to declare your unions, how to create variables for your unions, how to access the members of the unions. Most of the parts will be same, just like your structure. Okay, the only difference between a structure and a union is in the terms of your storage. Okay, the only difference between the structure and the union will be in storage processing only. So what is that thing? What is the difference here? In structure, each member has its own storage location, whereas all members of the union use a single shared memory location which is equal to the size of its largest data member. So in a structure, we will be having a separate location for each and every individual element for your structure variable. As you have seen, they will be stored in continuous memory location. For your book example, you have seen book name will be having 1 byte of memory, book price will be having 4 bytes of memory, and book pages will be having 4 bytes of memory, and all 9 bytes of memory will be present for one book. Okay, so that is what it has. One storage location for each member, that is for each member, that is price, pages and name. For each member we are having a separate storage. But in a union, all the particular, that is your pages, price, name, whatever may be, all these variables, all members of your union will share one memory location which will be equals to the largest size. Okay, for example, the size of your pages is 4 bytes. This is 1 byte, this is 4 bytes. So the largest, so we will be having only 4 bytes of memory. You will not be having 9 bytes of memory like your structure. In union, you will be having only 4 bytes of memory, which is equal to the size of your largest data member. The largest data member is 4 bytes. So we will be having only 4 bytes of memory. So this implies that although a union may contain many members of different types, so just like structure, it will be having members with different types, it cannot handle all the members at the same time. Okay, so the difference is, in a structure you can access the name, pages and price at the same time. Okay, but in a union you can access only one of them at a time. while you are accessing name, you cannot access the pages. While accessing the pages, you cannot access the price. While accessing the price, you cannot access other two members. At a time, you can access only one member of your union. Okay, so this is the differentiation between structure and a union. So if you see an example regarding this, so a structure will be declared in this manner where you will be having struct EMP, a union will be declared in this manner union EMP, and you will be having members char x float y, char x float y, okay, and you are creating a variable E and variable E here. Okay, so you are creating one structure variable and one union variable. So when you see char x means it is 1 byte and float means it is 4 bytes. So since it is a structure will be having memory for each and every variable. That is, when I create a variable E, so the structure variable will contain both x and y memory. That is, there will be 1 byte for x and 4 bytes for y. So complete 5 bytes of memory will be assigned for one structure variable. As I told you, when you go for your union, it is about memory sharing. So what is the largest memory you are having? This is 4 bytes. So the largest memory will be created for your union. So only 4 bytes will be created. So at a time, either x or y can be present in this memory location. Okay, so when I create a variable E, that is the union variable, the union variable will have only the 4 bytes of memory, which is equal to the largest member. Okay, and at a time while you are accessing, you can either access x, that is, you can perform E dot x or you can perform E dot y. Okay, but at a time only one value will be stored in your memory. If you are storing E dot x, your E dot y value will not be present. If I store E dot y, your E dot x value will not be present. Okay, at a time you can access only one member for your union. This is the differentiation. So the recap is, the structure and union both are almost similar except in the memory part. Okay, in a structure, each and every member will be having a separate memory, but in a union, all the members will share the same memory. Since they are sharing the memory, at a time you can access only one member for your union variable. If you see an example regarding this, so this is where you are creating a union with the 3 members. One is A, B, CH, that is, one is integer, one is float, and another is char. Since it is a union, so the maximum size is 4 bytes. It might be int or float. We are having the maximum of 4 bytes. So for a union variable, you are going to have only 4 bytes of memory. So first you are creating a union variable in main. So it variable, it.a we have assigned it as 12. Okay, as I told you, we will be having only 4 bytes of memory. Okay, when I create a union variable it, now it has only 4 bytes of memory. So it.a is equals to 12. At this instance, we are going to store the value 12 in A. Okay, now this is A. Now it.b is equal to 20.2. So since it is having only one memory, now this will be replaced by 20.2. Okay, your 12 will go and you will be storing only 20.2. When it.ch is equal to z, what will happen? Now b will be removed and this particular value will go and z will be stored in your 4 bytes of memory. So when I print these 3 values, that is it.a, it.b, it.ch, okay, since there is no value for your a, it will print some garbage value. Okay, since there is no value for b, it will print some garbage value. Since there is a value for c, it will print z. It will print z. So as you can see from this, at a time you can store only one variable and you are storing ch here, since this is the last assignment statement you have done for your union. So this is regarding the differentiation between your structure and a union. In a structure you will be having the complete this 4 bytes and 1 byte separately. So you can access them all the times. But in a union you will be having only one memory, and that memory will be equal to the size of the largest data type, and you can access at a time only one. So this is regarding your unions. And the last topic is in Typedef. Typedef is a keyword used in C language to assign alternative names to the existing names or existing data type names. Okay, whenever you want to have a new name for or alternative names for existing names, then you will be using your Typedef. Okay, so you will be having names, those names can be replaced by using your alternative names. It is mostly used with your user defined data types, where names of the data types become slightly complicated to use in your programs. Okay, whenever your name of your whatever the declaration you are doing, if it becomes slightly complicated, with that particular name can be replaced by using Typedef. Okay, so the declaration of Typedef will be in this manner, where you specify the keyword Typedef, then you write the existing name, that is Typedef space existing name, then place the new name or your alias name. So this is an example regarding your declaration of Typedef. So you are having a data type called as unsigned long in your C language. Okay, so instead of writing unsigned long in your C language, you can have your alternative name here, that is Typedef. Unsigned long is your existing name. Okay, you can have your name as ulong. Okay, if you want to use rename your int as some alternative name, you can Typedef it, and from that part of the program you can use this particular word as your data type. Now I can create a variable mine m1. Okay, now m1 will be one type of your integer. Okay, in the same manner you can create your existing name, you can create new names, alias names for your existing names. Typedef your existing name and the new name. From that point of time you can use that new name to create your variables. So that is regarding your Typedef. So apart from that one, the Typedef can also be used to give names to user defined data types as well. Your user defined data types like arrays, structures can also be given a new names by using your Typedef. For example, Typedef struct. So you have already created a structure. Okay, you can give a new name here. You can give a new name here. So when I give a new name, from that point of time, so whatever may be this structure name can be used to create your variables. Usually how you write struct book b1. So this is how you create your structure variables. Each and every time I have to specify this particular thing. Instead of that, I can create your Typedef struct and create all the members. Before closing, I can place it as book. Okay, so now this will be a book structure. From that point of time, instead of writing struct each and every time, I can use your book to create your new name, book 1, book 2, book 3, like this. I can create the structure variables by using this name, book. Okay, so instead of having large or long names or complicated names, I can use small names by using your Typedef. Okay, so this is how you can utilize your Typedef. And in this session you have seen about your Typedef structures and unions, the difference between structures and unions. In the next session we will be going for a new topic. Thank you.